Guys, today another podcast. Alex and Andrew here. It's Inside iOS Dev, episode
Four?
4. Yes.
Yeah.
Today we're gonna talk about Sandy Matt's book called "Practical Objective-Oriented Software." Oh wait, Design in Ruby. And you might be wondering why, Ruby on an iOS podcast, and we'll
Yeah.
get into that. And we're going to talk specifically about unit or testing chapter, I guess.
Yes. The last chapter.
Right, the last chapter of the book, which is a very, as you said, dense and
It's very
beefy-
dense. It could have been a book on its own, basically.
Yeah, but it has a lot of a lot of important things in there.
Yeah.
That are very helpful for any developer, really, not only Ruby people.
Yes.
And this is why we're talking about it. But anyway, let's start with again, right? The book is Practical Objective Oriented Design in Ruby by Sandy Matz, and she is a very well-known figure in Ruby community,
Yes.
and she knows a lot about OOP, right?
Object-oriented
Programming.
programming.
Right. So yeah, and so you recently, Andrew, he's been reading the book for the last months, right? Maybe.
2 days. No.
Right.
No, last month. Yeah.
So can you maybe give us an brief overview, what it is, what it's all about? I mean, besides the title.
The complete guide to writing more maintainable, manageable, pleasing, and powerful Ruby applications.
He's reading from the back of the title.
I cheated. This guide will help you understand how object-oriented programming can help you craft code that is easier to maintain. Basically, this is a book about designing object-oriented applications.
Right.
With
With examples.
code examples. She'll start off with a naive solution, some simple class, and show the evolution of the application as new requirements come in, and be this is not working. We need to use this technique instead. And then 90% of the book is that, and then at the very end, she's like, "Oh, by the way, you need to write tests."
Right, because you want to make sure your software, your application still works as expected, right?
Right. So then the last 10% is about testing, which is an entire topic in itself. So that's why I was saying, this could be a book in itself. And it was pretty dense. I actually had to stop midway through the chapter to watch one of her talks to help, clarify some of it more, which helped a lot. That's the overview of the book, and more specifically the testing chapter.
Right. And the reason you kind of found that book, I mean, we keep talking about it around the office, right? It's I guess our Ruby developers and myself.
The back end is written in Ruby,
But-
and we have we have Ruby developers here, obviously, and it's been recommended by you, Thomas,
Oh, yeah.
several people.
And for me, I have Ruby and Rails experience as well. And for me, that was one of those books that's was eye-opening, actually, in many ways. So, yeah. And again, Ruby, it doesn't matter really what, it could have been Java or any other language. And I'm currently reading Refactoring by Martin Fowler, which has Java examples. But at the end of the day, what matters is concepts and
Principles.
ideas and principles and
Yeah.
that they're talking about in those books. Cool. So unit tests or tests, what are they, right? Why they matter? Did she mention anything?
She did, and I don't. Let's see. Unit tests basically are testing at the object level,
Right.
and then in the book she differentiates from unit tests. I think the only other one she mentions is integration tests. So she says this is not about integration testing. This is about unit testing. So, or not on the object level, but on the class level. So you test basically the class to see if it's working correctly.
And I guess the main idea and difference between unit testing and integration testing is that, I guess, in their names, the core of it. With integration, you test the whole integration, how the system integrated throughout. I guess
The integration of the whole
its
system.
whole, yeah.
How
And
it works together.
right. And with unit tests, it's individual units of your system that you are testing and verifying that they work.
I think the analogy she used was like a biological system. Like you can think of the unit test as like the cells. All the cells have their own little jobs, and they're these tiny little units. And then you have the organism itself, which is made up of like a whole bunch of those cells. And from these simple things, you get complexity. And so the unit test is saying like, let's test a cell, and the integration test would be testing the entire organism.
Exactly. So yeah, the interesting thing though is that, again, right, even though all of the examples are in Ruby, it is still useful for iPhone developers and iOS developers. And Objective-C, who are working with Objective-C or Swift, it's still useful to read and kind of, again, understand the concepts she's talking about. So with iOS world though, the problem usually in the community is that tools are not there, and Ruby community embrace TDD, test-driven development.
Right.
But as far as I can tell, I see that slowly but surely iOS community kind of starts to, get to TDD.
Yeah.
And start to do it more. It's harder with Swift in some regards, but
right.
It's less dynamic. And one of the reasons why with Objective-C it's easier because it's closer to Ruby's duck typing in some sense.
Mm-hmm.
But anyway, the main thing is that the software, the best practices building software is that it should be tested.
Right.
Maybe not 100% coverage, and we take a different approach ourselves here at Vanilla, building our app, right? Where we obviously don't test everything, and we pick and choose what exactly to test.
Right.
But that's, I guess, a different conversation. Back to the chapter, right? What are the main takeaways for you were from that chapter? Kind of talked about it today.
We talked about it this morning, but I also was not being recorded and
Right?
pressured.
We should have.
Pressured by that, so.
So I guess the one thing I can recall is that in that video that you said helped to understand the chapter, she had this table with I guess things that are testable, and then she said, oh, you should test this stuff but should not test the other stuff.
Yeah, so actually this is probably one of the main takeaway. In the talk that I watched, she has this table, and unfortunately the table, I'm pretty sure it's not in the book. It's not in the book. But the table has on one axis, it says where the message is sent. So a message could be sent outgoing, it can be sent to self, or it could be...
By message you mean, hold on. By message you mean methods called on
method
objects.
Calls basically,
right?
on objects,
Mm-hmm.
yeah. So you could be sending a message to self, it could be outgoing, or it could be incoming. And this is all within the context of a class. So those are the three places that the message could send. And then there's two kinds of messages. There's a query and a...
command, I believe.
Command message. So then now you have this grid.
And in one case, query method will, it is what it does what it says, right? It queries something, some data. So basically it returns something. And a command one, as far as I recall, it's the one with side effects, quote unquote.
It has side effects that other objects can observe. So I think the example she gives is like writing to a database or something like that.
Mm-hmm.
Now other objects who are reading from that database will observe that side effect.
Right, if they are observing the database.
If they're observing the database, correct.
Right. And sorry, you were saying that in the
Yeah,
testing
so
part?
so now we have this grid of 3x2, which creates 6 little squares on there.
I
And
should get a screenshot or something of that.
yeah,
Maybe
it's
put
really
it on.
helpful. And basically, she says messages sent to self,
Uh-huh.
you don't.
So the private methods, basically.
Yeah, private methods you don't
Test.
and outgoing messages that are query messages you do not test.
That's interesting.
And then you test outgoing command messages.
Right, for the side effects that they make, most likely.
Yes. And then methods that are messages that are incoming to self, both query and command, you should test. I think.
Right.
Sure.
So okay.
So that's three of the 6 on that grid you test. Of those like classifications of message sense.
Interesting. Yeah, I mean, I watched that talk myself at some point a long time ago, and I don't really remember those specifics. Kind of to me, the rule of thumb was when you test public methods, right? And you basically don't test private methods on your objects.
Right.
It's kind of the main thing, because really your internals, private methods, it's internal kitchen. It's like the analogy was, I'm not sure if she made that analogy but I've heard it so many times. When your public interface, like imagine a restaurant, right? You came in a restaurant and you sit at the table and you about to order something.
Right.
You pull up a restaurant's menu, and that menu is a list of methods, right? Public methods are that menu.
Right.
And you select something from the menu, and then the waiter or waitress take your order, and then they go and pass it to the kitchen. And kitchen is your private methods, right? You don't care, you don't know, and you don't really care how it's done there in the kitchen.
Right.
And they can rearrange everything the next day and do it different way. What you care about is the final result, your meal that you're getting, basically.
Right.
Yeah. So, interesting. Yeah, we should have put it.
She also mentioned, this is like another thing that I noticed, deleting unused interfaces. So basically, she's saying like, if you have a method in your class and it's just sitting there and no one's actually calling that method, then delete it. Which to me was kind of obvious. I always delete methods that are in there that are not being used. Like, I guess for that, some people might be like, let me keep this method around because, maybe it might come in handy and I don't want to delete it because someone did this work. But to me, it's always been intuitively obvious for me to delete them because, like, I don't want to have to, like, read this code that's not actually being called. I love deleting code. So I would just remove them.
Right.
But that was in there.
She, as far as I can recall, she had a similar note on the removing tests that don't really have any value anymore. Or something about that.
I think in general, I don't know if that was actually in here or not, but in general, she supports removing code that's not actually useful because you just like, you're creating like this tight, the way she describes it, I think is like this tight coupling between objects, and like the more you have, your application just becomes this like tight thicket of code, and like you change one thing and it affects another thing. So if you could just like have as little code as possible that gets the job done, then that's more effective.
Yeah, right. And it improves maintainability, right? Basically, you clear out the code and you use only the things you need. And I guess if you keep things around and maybe abstract things out prematurely, a unnecessary abstraction is actually worse than, a more concrete and specific thing today. Because you hope in the future you're going to use it, but since you don't today, it's just simply increasing complexity for you.
Right, which she actually mentioned in the book in an earlier chapter. She basically says the same thing that you said. The other thing that she also talked about in this chapter was a dependency injection.
All right, it's a big one.
Yeah. So basically, I've always done dependency injection here because it's just always been the way we do things. Like I was just told, inject your dependencies. It makes your life easier.
Right, and we use, at least the legacy code uses objection for that. That's like a framework to do that.
Right. So the legacy code uses objection, which is a framework for dependency injection, and now we have decided going onward to just do it manually. So in the init,
Right, through initializers.
through the initializer, we just pass in the dependencies that we're using. And I guess like I've always had a hard time understanding why we inject dependencies. Because I really don't write tests. So I don't think I've ever felt the pain of not having dependencies injected because in dependencies injected because I don't write tests, which I know is bad. Which is why I'm reading this chapter. Which is why I've been pressured to read this chapter. So like basically she just explains like, oh, when you inject your dependencies, you can like basically configure the object. Like, so I don't know, if you have some class that you're testing in, like if you're passing in the one of the objects that are going to be used, one of the dependencies, then you can like outside of the test configure it however you want.
And maybe mock and stop
Like
things.
mock and stuff and things like that.
Because it's not the system under test, right? That's the terminology, I believe.
System under test, she uses object under test in this book, but it's essentially the same thing. And yeah, so you can like basically like configure this thing and like stick it in there. Versus like if you didn't inject your dependency, you would have to. It would just sit there. It'd already be in code, like being created by that class. So you wouldn't be able to configure it. So the way I thought of it is like, oh, you can either like just have this like, if you inject your dependencies, you can just like configure it and stick it in. Versus if you didn't inject it and it was just in the class, created there, and then it's just like pre-molded. And now you cannot like configure this mold. It's just like how it is, which makes it hard to test.
Right.
So I get like a better understanding of like why we actually inject our dependencies.
And I've been reading lately, it's also injecting dependencies actually helps you, I guess, conform with open closure principles.
Mm-hmm.
So open close principles. Basically, that's one of the solid principles. Solid. I don't know how they're like fully named, but solid something principles.
Yeah.
Those are the principles of good objective oriented design, and one of them is open closed principle, which states that your class or your module, whatever they call it, should be open for extension but closed for modification. And dependency injection precisely gives you that, because if you have a class and it depends on another one, let's say, I don't know what, a good example in iOS that pretty much virtually every developer builds is some kind of networking code, right? And let's imagine you have like, you build an application that manages posts with comments. So you have your post service that its job, its single responsibility, which is another principle, one of those principles, right?
Right.
Is to fetch those posts from the backend, and the way it does it, it needs to send an HTTP GET request, right? But that request is handled by a API client object. So with this open closure principle, your post service depends on the client, API client object, and you would inject it. And that way, if later you ever want to change your API client, its behavior and how it does HTTP requests, or maybe even use something else but HTTP, you would just simply inject another object of that type in the post service. And that way, it conforms to that principle, right? It's extendable, but we did not modify it because we didn't have to.
Right.
We just injected a new thing inside.
Right.
And we rely on abstractions and protocols. And I guess in case of Sandy, as far as I remember, she made throughout the book, she was talking about duck typing and like interfaces. But in Ruby, the way they're implied, right? They're not explicit because they don't have types that way.
Yeah, there's no there's no explicit interface.
Right.
Yeah.
But then again, like the big one, the big thing in that chapter, the testing chapter that I remember for me was testing behavior of things. I
Okay.
forgot the way she done it, but basically she was able to kind of say that, oh, when I test this thing, it's supposed to behave like that type, right? And in that way, you with tests you verify that it, can reply to those messages.
Oh yeah, yeah.
And well, yeah, basically confirm that it works the way you expect.
She actually, yeah, she does that. In some of the tests, she has assert respond to.
Right.
So, like in this example that I'm reading here, she has a bicycle class, and the bicycle class has an interface. So she has this bicycle interface test. So if you create a subclass of a bicycle, you want to make sure that it has implements all the methods of that interface, So in there, she's like, test responds to default tire size. And then it's like, has this assertion, assert respond to that the object responds to the method default tire size. And then test responds to spares, assert respond to spares. So yeah, that's a way of like making sure.
And I guess it's in a way a bit redundant for like a language like Objective-C or Swift, because you have your protocols for that.
Right.
But not, well, to a degree, right? With these assertions that it just responds to a method, she just checks the interface basically, right? But I think later she checks the results of that too, and that's kind of what tests supposed to do. They should check that by calling that method. First of all, you already check that if you can call it and compile in our case, right? That means it's already there. But the second thing you check is that the response of that thing is actually correct.
Yeah, she also has this test forces subclass to implement default tire size. So you have a method in the abstract bicycle class that's called default tire size, and if someone subclasses it, you want to enforce that someone actually overrides that default tire size method, and then she gets like assert raises not implemented error.
Right.
So
it's their way of doing abstract class, right?
Yeah.
We kind of do the same in our code base, I believe. That macro we have.
Oh yeah, we have a macro we have where if you don't implement it, it crashes basically.
Right.
But yeah. So yeah, that's in there.
Cool. Yeah. So I guess this is kind of the long-winded overview of that chapter, but a lot to talk about there.
Somewhat meandering, you might say.
Well. But yeah, I think later we would kind of bring that book again to our discussions because it kind of comes up now and then.
Oh, the book's really good. I liked it. I would like to reread it in like a few months' time.
Right.
Yeah.
And and when next time we'll discuss some other iOS topic, and again, right, most likely that thing will come up as we talk architecture and implementations.
Yes, and I need to start writing tests, and this was a good primer to it. And I know I said I don't write tests, but I know a lot of y'all don't either, because I know this iOS community.
It's just so unfortunate. It's for me. It's coming from
like that's just like how I was like that was the environment I was raised in basically as a up and coming iOS dev. It's like no one really talked about tests.
Because it was hard.
But now you're trying to get me on the train, and I want to get on the train because I know it's the right thing to do. So
it's tools, and it's the way you do it, and it's the compilations. All of that is different from Ruby. Well, I guess we'll talk about it in a episode just about that. All right, guys. So this was Inside iOS Dev with
iOS Dev.
Awesome
with Alex and Andrew
logo. Or what? How did you call that?
Wordmark.
Yes.
Yes.
But yeah, we'll be here next time, probably in a week,
Yeah.
with another episode talking about iOS things.
Please like, share, subscribe, comment, rate, review,
Yeah, just
everything.
anything you can do, please give us thumbs up there, because that would really help keep that thing going.
Yeah.
All right, guys. Bye.
Bye.